The skill programming language provides many functions for iterating over a block of code, with the for loop, the while loop, and the for each loop being the most common mechanisms for looping. We'll show a quick example of each of these looping structures using an example that we had used in a previous training byte. In this example, we roll 2 dice, and then have a case function that runs a branch based on the value of the dice. A for loop allows us to run a block of code a specific number of times. We'll add an argument to our function that will accept an integer, and then roll the dice the number of times indicated by the integer using the for loop. The for structure requires an iterating variable. We will use x, an initial value for x, we'll use 1, and an end of value for x, which will use the numerals integer that is being passed into our function. We'll close our for loop with a close parenthesis, and all the code in the for block will be run with each iteration of the loop. The loop will set x to the initial value of 1, and automatically increment x by 1 with each iteration, until x is greater than our ending value of num rolls. If we load and run our craps function passing a value of 10, then 10 rolls of the dice are run. It is worth noting that the skill for loop is slightly different than other for structures such as in C or Java. Our control variable can be changed inside the for loop and it will use that new value for that iteration. But with the next iteration of the loop, the control variable will be set back to its iteration value, and incremented by 1. Inside our for loop, we'll increment x by 4 and print its value to see that we have changed it, but at the end of the loop, our control value is reset, and our loop will still run num rolls or 10 times. Notice that if we load and run our function, it still loops 10 times even though we have incremented x inside of our for loop. Another way to iterate is with a while loop. A while loop will continue to iterate until a specific condition is no longer met. Let's change our function to iterate until we have rolled 10 naturals, a 7 or an 11. First, we'll change our argument name to num naturals instead of num rolls, and we'll use a while loop instead of a for loop. The first expression in a while loop is an expression that must evaluate to a non-nil value for the loop to continue running. Before starting our loop, we'll initialize the counter to 0 and increment our counter by 1, each time we roll a natural. We'll set our while loop expression to counter less than num naturals. Our while loop will continue to run until this expression is no longer true, so we will now continue to roll the dice until we have rolled the number of naturals that we pass into our function. Let's load and run our function with a value of 5, and we see that we continue to roll the dice until a natural has come out 5 times. Another type of looping structure is a for each loop. A for each loop will iterate over a list of items until the list of items is exhausted. Let's change our function to accept a list of dice rolls and iterate over the list of rolls once for each roll in the list. We no longer need our counter and we'll change our argument to be a list of rolls. We'll change our while loop to a for each loop, and the first argument to the for each loop is a variable that will be local to the for each loop, and this variable will be assigned an item of the list dice rolls, with each iteration of the loop. Each item in our dice rolls list will be a list of 2 integers that represents a dice roll. So instead of using random numbers, we'll extract the dice values from the 2-item list. If we pass our function a list of 5 dice rolls, then our loop will run 5 times, once for each item in the list. Let's load and run our function, passing it a list of 5 dice rolls to see our for each loop run. Our loop ran 5 times, but notice that our function now has an inconvenient return value. The return value of a for each loop is the list of items that were iterated over, and since the for each loop is the last expression in our let function, the let function returns the list, and in turn, our function returns the list of items that were iterated over. Let's return the number of items iterated over instead, by adding the expression length, dice rolls, after our for each loop ends, so that our return value is now the number of items that were iterated over. In summary, the skill programming language provides many functions for iterating over a block of code with the for loop, the while loop, and the for each loop being the most common mechanisms for looping.